Hi, this is the video to introduce the final project by Kyle Ming and Junai Yang. So the video will be consists of the mainly three parts. First, we're gonna introduce our game briefly, and then we're gonna explain how we set the positions of the traps inside the board, and how we made the pathfinding algorithm that check if randomly made board 6x6 board ensure there is always a path from each starting point to an ending point. And as the last one, I'm gonna play the game and explain how our code it works inside the interface, and checks it really works well inside the game. So for the final project, I and Kyle was inspired by the lab section that deals with the making board using the like nested list. And after talking about the final project theme, we decided on making a 6x6 board game and placing a traps, and each player should reach the ending point, like uh, avoiding dodging all the traps and find their own path to the ending point. And yeah, and that's the how briefly the game works. And to make a board game, the most important part of our program was after building all the blocks and the players code, we had to set the positions of the traps inside the board, and also we have to ensure those traps are they always ensure their path from each starting point and to the ending point. So for that, inside the displace random traps on board of blocks and pick random numbers block, we limited the number, the possible cases in which there is no path. Like for example, if there is a trap inside here and here, there is no path for the red player to finish the game, and this is impossible to finish it. So we're gonna we did limit those cases to simplify our pathfinding algorithm, and using this block finds the no, not finding. So this block really checks if each player has their own way to their ending point. So for sake of the reduced complexity of our program, we made a as I said before, we limit the positions of the block of the traps that which are placed on both of these or this, these or this, these and these and these and these and this. So using our own computation of the board, we limit the number of the positions, a number of the traps that can be placed inside these kind of cases. So after so after like each board has their own traps and ensuring there's a path from the starting point and the ending point, the game can really start. So uh, as a regression, we used to have a problem where the pathfinding algorithm used to stuck into the infinite loop. But however, yeah, it was the hardest. No, it was the hardest part of the to finding the finding the infinite loop sections. But we figured it out after skimming through the programs. So this is how we gonna start. So we're gonna show you how the game works using the board diagram, which shows all the traps inside here. So we're gonna start. So we did click the one game, and there's a traps locations inside the board. And if you touch the traps, if a player touched the trap, like the player will go back to the starting point and it all over again. So let's start from the red one. So if the red player starts first for this game, And if it goes up, right, right, up, right, and then it touched the trap. And after whenever it touched the trap, the X mark we made it for ourselves appears, and the player goes to the starting point again. And the turn goes to the blue player. And if it right, right, up. It is same for the blue one. So let's just show what happens if a player ends to the end point before the others. So if a player reaches the ending point before the other one, the player wins the game. That's how the game works. It's a kind of simple. And I'll show you for the different cases for the blue one. The case of blue one and wins. And yeah, it's same for the same for the different cases. So making this program, we think the most important part of this game is that each player should memorize the locations of the trap. And yeah, we're a bit simpler to like figure out the locations of the trap because we know how this kind of this like trap placing algorithm works inside there. But if a player doesn't, yeah, he does, yeah, player should like memorize each trap location well. But if you can memorize like up to like 2 to 3 of them, I think it will be much easier to finish the game. And now we're gonna do it without like without shading the board. Okay, and we're gonna turn off the board variable inside here, and then we go up here. So clicking the board. So when we click the start, so when we click it, there will be a message processing, but the pathfinding algorithm and really finishes fast, and ready message comes up when we can start the game. So for the red one, I'm going to start with the red one because red one always starts first, like the black in the go. Like well, red one go right, and there's a trap. So there's a trap inside there. So a player should memorize well, but because I'm doing for both of it. And for the blue one, goes up, up, and there's a trap inside there. Traps in here and here. So for the red one, so considering an algorithm, there can't be the trap here. So we can go up. If the red go right, there's no trap. Up, there's a trap. So for the red one, no, there's a trap here, here, and here. And then for the blue one, up, up, left, up, up, right. Oh no. So there's trap in here, 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 and here. No, is that here? Right? I remember this. So okay, for up, right, right, up, right. Okay, there's a trap here, here, and here. Up, up, up. Yeah, sometimes people make stupid